will explain a very easy way to learn the Bernoulli's principle. Essentially, Bernoulli's principle is just conservation of energy. If you consider a liquid flow, it has three main energy constituents. The first one is kinetic energy. Since there is a very steady flow of mass, it is very easy to see that a kinetic energy is always involved in it. The second one is gravitational potential energy. During the flow of water, different parts of the channel could be at a different height. Hence, the potential energy at different parts of the flow are going to be different. So, whenever we are considering the conservation of energy, we always have to take in account of gravitational potential energy. Now, the third component of the energy is something called pressure or pressure volume energy. It is a kind of energy that is available only to fluids which are kept under pressure. Whenever we consider a fluid which is bound or restrained by some other object, we always see that it has a tendency to move out. But it is this pressure that keeps the fluid within the container and to take the shape of the container. So in a sense, it is also a kind of potential energy, and if we release this pressure, we can see that it gets converted into movement. That is, the pressure volume energy gets converted into kinetic energy. Easiest example could be releasing air from balloon. We can see as soon as we release some of the pressure, its pressure volume energy gets converted into kinetic energy and the air rushes out of it. From these three, we can write the conservation of energy as kinetic energy plus gravitational potential energy plus pressure volume energy equal to a constant. That is half mv square plus mgh plus pv equal to constant. pv is the pressure volume energy. But there is a small problem. We cannot use this equation directly, because when we consider the system, which is the mass we are considering? If we say it is a continuous flow, there is a continuous flow of mass and the total amount of mass would go to infinity. Again, if we are trying to consider a small time period or a small area or a small volume, it is not defined which is the small time period or the small segment of the channel we should consider. Again, if we look at the pressure volume term, if we are considering a long channel, it shouldn't change. Something that we write for a very general system shouldn't be dependent on the length of the channel. And again, if we consider like an infinitely long channel, we will get the total energy to be infinite, which again serves no purpose in solving these equations. And we can see that the energy of the system is increasing proportional to the volume of the system. The larger the volume we consider, the larger will be the amount of energy we are considering. So, to get the final equation from our basic half mv square plus mgh plus pv is equal to constant, we divide it with the volume. When we take the ratio of mass to volume, we get the quantity called density. So, if we are dividing the earlier equation by volume, we will get the equation half rho v square plus rho gh plus p, where rho is the density of the liquid or any fluid for that matter. So, for the conservation to hold, this quantity should remain constant. And this is exactly what the Bernoulli's principle says. This one is the most commonly used term for Bernoulli's principle, that is half rho v square plus rho gh plus p equal to constant. And in some other places, and another way of writing is by dividing the earlier equation by mass. So if we divide the first equation half mv square plus mgh plus pv, if we divide it with mass, the mass terms in the kinetic and potential energy will vanish, and in the pressure volume term we will get a quantity V by m, which is the inverse of density. So the final equation will be half V square plus gh plus p by rho equal to constant. And that's it. We have found a very easy way to learn the Bernoulli principle. So all we have to do is check the conservation of velocity, conservation of energy, and divide that term with volume, and we get the final equation for Bernoulli's principle.